right, 3-4 solving 2 in multi-steps inequalities is really nothing new. So we're going to go through it relatively quickly. We're still solving for x. We have our brick wall. Remember, you want to save the best for last. So subtract 6 from both sides. Negative 12 minus the 6 is the same thing as plus negative 6. So negative 12 plus negative 6 is negative 18. Bring your inequality sign down. Is greater than or equal to 3x. We're still solving for x. Since it's times 3, you have to divide both sides by 3. We still keep our greater than or equal to because this was positive. It stays the same. So it's greater than or equal to x. Negative 18 divided by 3 is negative 6. Now when I graph, I like my variable on the left. So I'm just going to rewrite it as x is less than or equal to negative 6. Remember, if the tip is touching x, the tip is touching x. So then on your number line, remember with your negatives, if zeros here, you're counting backwards. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. It's going to be a closed dot because it's less than or equal to. And all the numbers that are less than negative 6 go to the left. All right, number 2. Now for this one, we're looking for n, but n's in the numerator. Remember, you have to go through the downstairs to get to the upstairs. So we need to get rid of our positive 3 here first. So we're going to multiply both sides by 3. I'm going to draw my wall to help me out. So 3's and 3's canceled. You have 1 minus 2n is less than or equal to 21. This one is positive. So to get rid of a positive one, I subtract 1 from both sides and have, don't forget to bring your negative down. Negative 2n is less than or equal to 20. Now I'm going to divide by negative 2. Because this was negative, I'm going to flip my inequality right away. Flip it, flip it. And I have n is now greater than or equal to negative 10. So you're going to draw your number line. Again, negative numbers go backwards. So negative 9, negative 10, negative 11. You have a closed dot. All the numbers greater than are on the right. Number 3, 2 minus a negative 10 is greater than negative 4t. The first thing I did was made this a big old positive. 2 plus 10 is 12, greater than negative 4t. So when you divide both sides by negative 4, you right away flip your inequality and get less than t, bring it straight down, and you're negative 3. But again, I like my inequality on the left. This time the open side is touching the t, so I have t is greater than negative 3. And again, we're going to graph it. Going backwards, negative 2, negative 3, negative 4. This time it's an open dot going to the right because those numbers are all greater than. Number 4, yay, we get to do some distribution. Negative 4 times positive 2 is a negative 8. Negative 4 times a negative 6 is a positive 4x, is all less than or equal to 8. Well, now we can just add 8 to both sides. And we have positive 4x is less than or equal to 16. Divide both sides by 4, and you get x is less than or equal to 4. So our number line just goes in the normal order. We could have 3, 4, and 5, a closed dot, and we go to the left because those numbers are all less than. Now this one, to get rid of your fractions, remember you need to find the least common denominator. In this case, it is from 3, 2, and 3, 6. So you multiply all, in this case it's 3, terms by the LCD. So I'm going to put times 6, times 6, times 6. Now when you multiply, it's really 6 over 1, 6 over 1, 6 over 1. So I say, well, 6 times 2 is 12. 3 times 1 is 3. 12 divided by 3 gives me, 12 divided by 3 is 4f, plus 1/2 of 6 is 3, is greater than 1/3 times 6 is 2. And then you just simplify or solve. So you subtract 3 from both sides, and you have 4f is greater than or equal to negative 1. Divide both sides by 4, and you get f is greater than or equal to. Make sure you remember this right here This is your fraction answer. So you get negative 1/4. So on my number line, again, I'm going to go backwards. I'm going to go 0, negative 1/4. And if I'm going by quarters, I'd have negative 1/2. It's a closed dot because it's greater than or equal to, and we're going to the right because those numbers are all bigger. Last but not least, number 6, it says the average of Ethan's 2 test scores must be at least 90 to make an A in the class. Ethan got an A on his first class. What grades can he get on a second test to make an A in the class? Well, first, let's see, what are we looking for? What grades can he get on his second test to get an A? So I'm going to say X equals the second test score. Now I'm going to go back and reread the first sentence. The average of his 2 test scores must be at least 90. So I know that the average at least means greater than or equal to, has to be greater than or equal to 90. Now, how do you find average of 2 things? Well, you'd add them up to divide them by 2. So you'd have your first test plus the second test divided by 2. That's how you find the average. The average is just all of this is greater than or equal to 90. Well, we know the second score was X, and the first score, he got a 95 on his first test. So I have 95 plus X divided by 2 is greater than or equal to 90. Well, now this is just like an earlier example. If we're solving for X, remember first you have to get rid of your 2. So multiply both sides by 2 over 1. Your 2's cancel times 2. You have 95 plus 1x is greater than or equal to 180. Subtract your 95, and you get x is greater than or equal to 85%. This one you do not need to make a list because you can have a decimal as your answer. Back here at the beginning, you could say, yes, decimal, which means no list. So you could, in fact, do that. Your closer, just go ahead and think about it for a minute without solving. Say whether the equations have a positive solution, negative, a 0 solution, no solution, or infinitely many solutions. Well, think. If you have something and then you add 1 to it, is that the first thing ever going to be bigger? No, that's going to be no solution. This one here, I just went ahead and I solved it. Subtract 7, subtract 7. So you get 2x is less than 0. Divide by 2, divide by 2, you get x is less than 0. That would be an infinite amount of solutions. The next one, 3b is less than or equal to 3b. Well, that's true. So there would be infinitely many. Infinitely many solutions. And these solutions would be negative. Here, you divide by 5, divide by 5. C is greater than negative c. Well, this again is going to be infinitely many. Okay, try these questions on your own and see what you get. Okay, for the first one, you should have first said that x equals the number of times she can play. Because I saw the word number, I know it's going to be a list. Then I know she brought $23. So what she spends has to be less than or equal to what she has. And she has $23. She purchased $5, so she spent $5. And now it's to play for $28.250 each, or per game. So I would do plus 2.5 times x. So I would subtract 5 from both sides and get 2.5x is less than or equal to 18. So divide both sides by 2.5, divide by 2.5, and you get x is less than or equal to when you divide 18 divided by 2.5, 7.2. So your final answer is she could play 0 times, 1 times, 2, 3, 4, 5, 6, or 7. She can't play 8 because it's less than or equal to 7.2 games. Okay, the next one, the first thing you should have done was distribute on the left. So you should have had 10 minus 5b is greater than, well, 5 squared is 25. This is a positive 10, so I subtracted 10 and got negative 5b is greater than 15. Divide both sides by negative 5, and you have to flip. So you had b is less than negative 3. Your graph, you would have gone backwards, negative 2, negative 3, negative 4, open, going to the left. Your last one, I thought that a common denominator between 5, 3, and 1 would just be, so you should get that your least common denominator equals 15. So then whenever you go ahead and multiply each of them by 15, and 15 times negative 1/5 gives you negative 3z, plus 15 times 2 is 30. 30 divided by 3 is 10, is less than or equal to 30. So then you can just continue solving. Subtract 10 from both sides, and you get negative 3z is less than or equal to 20. Divide both sides by negative 3, and make sure when you divide by negative, you flip your sign. See if z is greater than or equal to, how many times does 3 go into 20? It goes into it 6 times, and then you get 2/3 left over with a negative, and then make your number line going backwards. I just went negative 5 and 2/3, negative 6 and 2/3, negative 7 and 2/3, and then it's going to be closed because it's greater than or equal to. All the numbers that are bigger go to the right. Now you can go ahead and start your homework.